Okay, hello everybody. I'm just gonna need a few more minutes of countdown time, so I'm gonna restart the timer. It'll probably be less than that amount of time before it's ready, but I just want a few more minutes to get stuff set up. Back in just a second. All right. Good morning, good afternoon, good evening, everybody. Welcome to the February Rust Gamedev Meetup. Now, I'm super excited about today. It sometimes happens from like month to month where I'll put out like the meetup message like 2 days before the meetup happens, and then I'm like, oh my gosh, are there people to speak, all this kind of stuff. But there's so many people this month that have such cool things to show off, and so we'll dive right into it. We have, I think, 6 different presentations total. And so we're going to try to keep them going nice and quickly. As always, if you are in Discord, you can always be typing in questions or anything, and I'll check in with that. Or if you want to type in YouTube or Twitch. And so without further ado, we'll be back in just a second with the Blue Engine. All right, we're going nice and fast on transitions here. Looks like you're muted right now, Elham. Also, while you're talking, I'm going to try to get the videos for you set up, though I'm having some difficulty uploading them to 50-50, but I'll let you take it away.
Thank you so much. I'll let you know when to play the videos. It's gonna be a bit later, so take your time. Hello, everybody. How's it going? This is Ilham, and back with more Blue Engine news. It's been a while, but I've been busy with work, so I couldn't do a lot of updates. So instead, I'll be showing some minor changes that we made along with the community updates that I'm sure you're gonna like because it is really fascinating. I loved it myself too. So let's get started. Um, we're going to talk about a few things here. We're going to talk about the wireframe mode, scissor mode, some minor updates that we did, and a topic that was coming up a lot since the announcement of the engine, which is the game dev with the Blue Engine. If you don't know Blue Engine or you're new, Blue Engine is a graphics engine, mainly and primarily, that is focused on ease of use and being portable and flexible. The main idea over the Blue Engine is that it should be allowing anyone from expert to a new user to be able to use the engine in Rust. So that would mean it will give enough wrapper for a new user to be able to like easily use an engine to draw things, but also does not force you into a certain framework or certain way of working, so that if you are an expert into graphics, you won't have any issues updating the core level of the engines and changing things up from there. So we're gonna talk more about the game dev side of the engine later at the end. So for now, let's start with the updates that have been happening since we last talked here. The first one is wireframe mode. It is not really that impressive, but the thing that worked for the Blue Engine is that the wireframe mode is not global now. It is per object. So you can toggle the wireframe mode with just one setting inside any object that you have. And there are three options available, which are the dots, like the points on each of the vertices, lines, which is the normal wireframe mode, and the normal filling up, which is the default option that is used most of the time. Another thing is that the option is now available across any type of object and any size, but also only supports a few backend, for example, Vulkan and Metal, because backends like OpenGL does not support it according to the web GPU. So only a few of them support it, and those that do support it will have the options available by default. Those who do not, the option will just give an error. The second one is scissor mode that is flexible. So scissor mode basically allows you to render only on a small part of the window. We didn't have this before, but now it's available, and it's not. It had a lot of issues too when I first built it. For example, bounce was an issue. When your window is of a certain size, it would crash because of the scissor. But now all of those issues are fixed. The scissors are now working perfectly, so you can use it to display only a certain point of it. This can be useful if you have things like an editor, or you have an application that needs to draw the graphics only on certain size of the window. So if you have like an visual editor for your game or your tool, you'll be very much able to use scissor mode to only draw a certain part of it and have the rest of the window up to the graphics and GUIs. And moving on, some other minor update that we have is clear background, which is really funny because it took so much time. You couldn't clear the background from the default black, and yeah, now it's available. And the errors, we used to have just like anyhow for the errors, which was really bad. But I'm slowly transitioning into using IR and adding more errors and options for the error handling. Um, well, need some help from some community members for it, but so far it's going pretty good. But those are the minor updates that we have. There are a few others which I won't mention here because it's so small, and some more options in the future. We'll be discussing that when the time comes. Now, moving on to the juicy part of it is the game dev examples in the Blue Engine and how you would be able to make video games with it. The Blue Engine has come a long way, and mostly I didn't say it was ready for making games and it was really experimental with the API. But ever since the 0.5 update, a lot of things have stabilized. So it gives ability to make games with the engine now, which was previously a lot harder, and it was nearly impossible to make stable games or like games that run at all. Some community members have made a lot of custom benchmarks with it too, which was really interesting to see. Uh, Forrest, if you were able to like play the first video. Yeah. So the benchmarks that you're seeing here was running over 10,000 NPCs inside the game. It's running on a GTX 1050 on a GPU that the community member had. It's on release mode too. I don't know some other specifications of their system, but it was able to run a lot of objects. And on the GPU side, it had 23% GPU utilization. On the CPU, it was a lot higher, which is something I should work on. But yeah, I don't do a lot of optimizations on the engine yet. We don't have like Fresnel culling or occlusion culling yet. So this was interesting. And the second video that we'll see is the same community member, Nick Jason Hagen. He was able to add a lot of like gameplay elements to the test. First, if possible, can you play the second video? Yes. Um, as you can see, he was able to make 3D objects using just the quads that are available and the textures on them, and different viewports and like the camera and movement and everything, which by just that amount and the collision system that he made himself, you would be able to make RPG games, 2D games, and even 3D games, which are simpler games, let's be honest. You are able to like make games with the engine now, as as the example shows. And the member that made this, Nick, he wrote all of it on Nscript, which is a scripting language he himself made. In the last meetup, I was able to talk about Nscript a bit and how it's a plugin now. He ported all of the engine options into the Nscript. I think it's also available from the GitHub link that I'm showing here. There was some things missing, but you'll be able to find it on his profile. I'll be trying to talk with him to fix the links and issues there. But yeah, he wrote the collision system himself through the Nscript. He wrote the physics system too, and a lot of the tile map as well on the engine, on the Nscript. So it was really interesting because he wasn't using any extra thing that the engine was giving, and no utilities used. Basically, he did it all by himself, which was quite interesting, quite amusing too, because I haven't seen anyone else do that with the engine or really attempt it. Because most of the games that I see that the Rust community make is using the plugins that other community members provide, and usually people don't spend a lot of time building in-house tooling, which would be a great experience for a lot of the game developers, in my opinion. But yeah, those are the game dev journey that Nick Jason made with the Blue Ocean and script. Um, we can talk more about its progress as the time comes. He wasn't able to present these himself because he was a bit busy, but hopefully in the next meetup he'll be able to show you himself and talk about it, which I'm really excited about. But yeah, those are the changes and community updates by the Blue Engine. If you have any questions and if you have any feature updates or anything, you can join in the Discord server that we have, or check out the issues side, and we can talk more about the engine if you're interested. But yeah, if you have any questions, feel free to ask them, and I'll be here to answer.
Awesome. Yeah, it's super cool seeing sort of like the progress coming along, but also, I mean, we discussed this, I feel like last month, but the fact that you can be at like a pretty early place and then have someone come along and be able to like add stuff in is super cool. Now, we just did have a question right here in chat. How does the Blue Engine compare to Firefox and Bevy in terms of goals?
The goals of the Blue Engine is not to be a game engine. It's mostly just graphic side of it. But the Ferox has the market of having the visual editor of the game engines in Rust. The Bevy is more onto the game engine itself, like having a lot of ECS and focusing on games specifically. The Blue Engine is not focusing on either of that. The Blue Engine is focusing on graphics itself. So you could do things like having graphical applications with it, using the engine to make application itself, which I made. I made a few applications with the engine and using the engine to draw the GUI side of it. And hopefully in the future, it will be able to draw on Web 2. As of now, we don't support that. But yeah, the engine is focusing on being a flexible renderer and being able to just a small footprint to be able to draw graphics anywhere that you want.
Perfect. All right. Well, thank you so much, Elham. I'm definitely excited to keep hearing about this community progress. I think it's super cool seeing like the engines and like how it's being built, but also like sort of like what people are being creative with. And so I guess like the other question I sort of have, I don't know if I asked this last month, but when are you going to have the first Blue Engine game jam?
Oh, I'm really excited about it, but I'm waiting to have a lot more community members.
For sure. That's totally fair.
For now, we
All
have
right.
only 2 people making games with it, but if a lot
Yeah.
of people are interested, I'll be happily launching a game jam. It'll be interesting.
Nice. Good stuff. All right. Well, thank you very much, Elham, and I hope to catch you in a future month.
Thank you very much, too. Take care, everyone.
All right. So we are back here with our second project, Rivet. Now, a little bit of context. I mean, I saw this project quite a while ago, just kind of on Reddit, showing off that this is a sort of platform made in Rust. But since then, I've actually joined the dev team. And so this is my full-time work. And so I'm going to be doing like a little bit of an interesting sort of host aspect here where I know a decent amount about what's going on, but at the same time, I'm going to try to answer or ask the questions that other people might ask. And so, Nathan, I'll let you take it away. Tell us about Rivet. Tell us about what's going on this open source platform.
Yeah, today's going to be kind of winging it and doing a live demo. So hopefully you get to watch things fall apart as they do in my demo. I'm kidding. Rivet is a solution to help deploy and scale multiplayer game servers. So we've worked a lot of game engines. We used to work in .io games, if you're familiar with web games there. And so they always have the same issues with game servers of like, okay, now I have a game running on my computer, but like, how do I actually get it onto all these servers around the world and make it scale up and down automatically? So we're more at the infrastructure level instead of the game engine level of like, okay, can we take your Docker container, run out a bunch of servers and scale elastically and handle like huge surges of players? And obviously Rust is a great choice for that. So I'm going to jump into like a quick demo to give like an overview of what it can do. And let's hope everything stays together. So we have like a bunch of examples in this repository over here on GitHub, which you're welcome to dive into. We've kind of broken it down by language. We have a couple old side projects I used to work on for Rust games that are actually open source. And they're set up to run on Rivet. But we're going to go deploy the asteroids example here and kind of walk through that process of how it looks like. So the first thing I'm going to do is go make a game on our website. We can call it Asteroids Demo 2. And then what I'm going to do is actually connect to it from the CLI. So I have this project already cloned on my computer here. So I'm going to do Rivet init. This is going to take me to the browser to link to the asteroid demo. So here's that game I just created. Okay, click link. And now my CLI is set up to interact with the Rivet backend. And so this has access to all the clusters around the world. I think we have 8 regions right now, working on adding more. One big thing we wanted to work on at Rivet was like standardizing the local development process. So how do you make it so you have a complicated API that you have to integrate with to get your game up from your client to your servers and connect everything, but also not complicate your code. And so we have kind of a way of simulating a production environment on your local machine with a command called Rivet run. So you could do Rivet run server, and then Rivet run client. And you'll see here that on my machine, we have this game running here. It's a super simple asteroid shooter game, and you'll be able to play with me in a second. So now that we have this game running locally, we can go into our demo and we can run Rivet, deploy, and then to production. And so this is where kind of the interesting Rust stuff starts to happen. You'll see it's building a Docker file, which at the surface looks pretty straightforward. But under the hood, what we're doing is at this step here, we're taking the Docker file and then we're building something called an OCI bundle, which is actually a standardized format that is at the core of what Docker does, of how to run a Docker container. And the reason we do this is because we can actually optimize how fast containers start by stripping out all the bloat that Docker adds and then building our own custom format that uses LZ4 compression instead of gzip compression. And then has like a interesting edge caching system, which I can talk more about at some point. But now we've deployed this. This is now sitting on our servers. And you'll see you can go to asteroidsdemo2.rivet.game to play. And I will send you all a link in 1 second, but I just realized that all the regions are enabled, so we probably can't play together. But you'll see here that we're connected to a live server now. I believe this one is in Los Angeles. And we can go over to our dashboard, go into production, and see here's that server that we're just playing. Someone from Frankfurt just jumped on, I saw. And then you can jump into here and check the logs. We have like a log shipping system built in Rust that takes logs from the container and sends it over to ClickHouse, and then also collects live metrics on CPU and memory. Again, Rust has been like great for that type of thing because we were using tools that would take like 100 megabytes of memory just to ship logs, and that was kind of unacceptable. So we did it in Rust, and it takes less than a megabyte. So that's been great. Let me redeploy this with a only one region enabled. So rivet.yaml is our config here. Disable Frankfurt, and then we can deploy this again, and then hopefully everyone can jump on the same server and play the game. Some other interesting Rust aspects that are going on under the hood here is, so we talked about the OCI bundles. Those are all connected with Nomad. If you're familiar with Nomad, it's a orchestration tool to help run code just on servers. So it's like Kubernetes, but in my opinion, better built. But that's debatable. And then this example specifically was for an HTML5 or like a custom game with like a very complex engine. And so all the API integrations are done through basic REST requests. We also have a Godot plugin and a Unity plugin coming soon. And so we've been using Rust in an interesting way there, where we have something called a sidekick, in the sense that we want to build a lot of cross-platform functionality and cross-engine functionality, but you don't want to go rewrite that in GDScript and C# and C++. So inside the CLI, we have this hidden command called a sidekick, where we write a bunch of cross-platform code that we use within all of the engines. And in that way, the engines are only like a few hundred lines of code and everything else is done by the CLI itself, which is very cool. And it's made it really easy to run this on multiple platforms. Yeah, what games are we targeting here? So we started with IO games, which is like hyper casual multiplayer. But really we're built to work with almost everything except for MMOs. The tricky thing with MMOs is the way the lobby runtime like needs to be stateful. It's not something that we're set up to handle right now. So it's best handled for like match-based games. So like a first-person shooter or like something that does not need to run for more than like 3 hours at a time, if that makes sense. We do have some Rust games running on Rivet, which I will talk about briefly. One of them is this game called H.io. I highly recommend checking it out. One of my favorite games personally. But they built a voxel engine in Rust, and everything's done on WebRTC. I'll let you guys go check that out yourself because it's a very cool project. And then we also have another game built on Matchbox and Bevy, which is not out yet. But they're doing some really cool stuff there, and hopefully we'll be publishing our Bevy support soon. All right, I just rambled for a bit. Happy to answer any questions, and thanks for posting the link in chat, by the way.
Yeah, awesome. Okay, so it's super cool. I mean, kind of like going through the process here of seeing it deployed and everything. So one question that I and this again, this is me having just read the Rivet blog post, but one thing I was quite interested about is like so when we're going and doing stuff in cloud, we can see examples of how I think like maybe Cloudflare is using Rust, or like these other cloud platforms are using Rust. And you talked about like how it's used in Docker, but what do some of the other services look like that are like making use of either like the same Rust monolith or infrastructure in that way?
Yeah, basically it's Rust everywhere. So it's kind of hard to say like what is not Rust. But we have a kind of a services system set up here. This is, let me grow the screen a bit, maybe so it can help. So in our repo here, let me switch over to the open source version.
Also, while you're doing that, I think someone in chat mentioned a while back, there's a Vim flex you got going on here.
Yeah, I'm big on NeoVim, big on Alacrity, the whole shebang. If you dive into a repo, you'll see there's something called a packages folder here. This is kind of where all like the Rust modules live. And so we built an internal system that we call Chirp, which handles everything from handling context to traces to logging to metrics to like durable queues, so like Kafka style stuff, and then like an API handler. So we've basically built a lot of this stuff in-house. And so at the API layer, you'll see we have, if you look at the matchmaker, for example, we have someone here who loves building proc macros. So we have our own custom router that handles things like rate limiting, serialization, deserialization, and like we really get pretty granular with our rate limiting here. We found that back at the time, I'm blanking the name of the web framework that was Warp. Warp was too slow for us, so we had built something internally in terms of compilation time. I'll just jump around the repo and show some other fun things. Let's see. I'll show the user thing, for example. So we have a system. Oh, this is also all built very tightly around protobufs. So everything is under the hood built to be like portable. You know, you can store it in KV. You can send it back to the client. We have a system called operations, which are kind of fun, where under the hood, most of the time it's just running a function, but you can actually make it set up to do an RPC call to another server. So anytime you call this operation, we're serializing a protobuf under the hood, and then where it gets ran is like, it doesn't matter, which lets you do a lot of really interesting things in terms of like separating services, like some services who have more like, you know, compute heavy things. If we did something down the road with the GPUs, like it's pretty flexible there. And then we also have under our workers, you can see, for example, though we handle user create, we've created this kind of serverless-esque kind of type environment where everything you write is very standardized and automated testing. So you'll see the worker is just like what you consider a serverless function. You pass in the context and the request, and then all the macros and stuff like that for fun SQL queries. I think this is one of those things where like I work with this so much every day, it's hard to remember what might be interesting to other people. So I'm happy to dive into like any part of this infrastructure that someone might be curious about, because most of it is built in-house.
Well, one thing I might be curious about, so if I was like just like a Rust developer, I'm working on like my multiplayer game, what would that look like integrating with Rivet? Like what would be needed there to build that bridge?
Yeah, so we don't have our Bevy and Rust like official libraries out yet. But we do have some Rust demos available. We did like a prop hunt game, for example, once. Everything in Rust is built to be like a very simple to use REST request. And we have that on our site. So Rivet GSS docs, you'll be able to see pretty easily everything you do. And so at the bare minimum, you can just make a curl request here, or a whatever type of request. And then that will give you the lobby you need to run. In terms of everything else in networking, we tend to try and work with open source libraries. So if you have a networking library and you think it might be interesting to help work with Rivet, I would love to chat with you. But so our philosophy is work with open source networking libraries and then just take care of the lower level server infrastructure and go from there.
Nice. And then finally, the last thing I want you to do, could you go back to the asteroids tab? I want you to, so we got like a few players in there right now, I think. But it's kind of cool to see just like everybody connecting together in a live demo here.
Yes.
And stuff working pretty cleanly.
So I think this is all running in Atlanta. So I apologize to anyone in Europe right now. I had to disable it so we could all be on the same server. I'm getting destroyed out here. These people have been practicing. Oh man.
Oh yes. And then one other thing I want you to show off here that we shipped recently is if you go to the Rivet website, like when I saw that people have been working on this, I'm like, oh my gosh, so cool. But you can actually play like asteroids on the page right there with other people who have their tabs open, and I think that's so cool. Yeah, so anyways, you can keep an eye on the Gamedev chat if anybody has any questions there. But yeah, this is super cool to kind of be able to see. So thank you very much, Nathan.
Yeah, thank you very much.
Perfect. We'll be back just a second with Tadeo. All right, so we are back with Tadeo, who's going to talk to us about an Untitled hex game that they've been working on. I'll let you take it away, Tadeo.
Yeah, hello everybody. The game doesn't have any name yet, but I'm working on a game which is basically a mix of 3 other games that I really enjoy. And let me share this here quickly. And the games are The Settlers of Catan. Maybe you know it. It's like a really nice board game you can play with your family or friends. The other game that really inspired me is Age of Empires, where you can, like, on a big map, you can place buildings, you can place troops. And another game I really like is Magic the Gathering, where you can play different cards. The cards have quite complicated effects, interact with each other. There are triggers that trigger other effects. And I want to make a game that combines elements of all of these. And the game is supposed to play on a hex map that looks a little bit like this. There's some in development footage. It's pretty early quite, so it doesn't look super nice. But yeah, the plan is that you have such a map, and then you can place your troops and buildings on that map and fight against other players. Yeah, for the development, I chose Rust because it's very performant and I can like work very quickly in it. And the experience until now has been quite nice. I first started out using the Bevy game engine, but after a few months, I found it a little bit limiting. And then I just went with a WGPU, just with the crate, and I can just write the shaders on my own, and I have just much more control over how the rendering works under the hood. There are some things I want to show you guys. So here is a little mock-up of what the game is supposed to be. You have some cards in hand, and then you can play them. You can see them in big, and you put them on the map, and you have different resources that are produced each round. So it's a turn-based game, and you fight against other players in multiplayer matches. I've already developed the server stuff for that, the networking and other things, and that's working quite well. But right now, the biggest problem for me are the graphics. Yeah, I'll try to boot up the game very quickly here. that you guys can see how it's running. So this is the little title screen for the game. Because it's a card game, it's like quite important to me to have good UI, because in card games you need to have panels and good font rendering and maybe shadows and everything. So I wrote my own immediate mode graphical user interface library for this. I'm currently reworking it because it's not so easy to write a UI library, but here you can see it in action. I have some buttons and I can click it. And if I click here to start a new game, it basically looks like this. We just have some world. The controls are not how they are supposed to be, but I can just fly around. And we have some card rendering here, for example, in 3D space. The plan is then that you have these cards on your hand and you place them on the map. But it's still quite early in development, so I don't really have that. What I have, though, is bloom. So, for example, I can turn the bloom effect here all the way up. And that works by rendering the entire screen to some high definition texture. And then I just take all the bits of that texture that exceed the value of 1, and I just downsample them, blur them, downsample them, blur them, and in the end I add it again on top of this image, which gives this effect that looks a little bit like lighting. Yeah, so the bloom is the only thing that makes the graphics look good. Otherwise, it looks pretty boring still. So I plan to have some animated vegetation here, for example. I want to have trees here and other things. And yeah, that's it about the game.
I think we might be losing your internet connection a little bit there today. I'm also going to bring up a ping on my side to make sure it's not my internet. Okay, I think I'm doing all right.
A little bit about a few technical things here that might be interesting to.
I'll wait for you to come back in. All right, we might have lost Tadeo for a few seconds here. So what I might do, I might pull us over to the next presenter quickly, and then we'll come back with Tadeo to do some questions here. And so I'll be back in just a second with Jan, who will be telling us about... actually, wait a sec. I might be able to pull Tadeo back in here. All right, I think you're back, Tadeo.
Hello. Yeah, the internet is quite bad here in Germany where I live. I just got a new internet provider, but it's not working how it's supposed to be. I'm really sorry for that.
No worries, no worries.
Yeah, I just wanted to spend like 3 minutes talking about some technical things here, what I do. So one of the things what you might render is how the terrain is rendered. And what we need to have for the terrain to render it is first like a map layout that shows the different terrain types. And what I do is I just draw some terrain in GIMP here as a bitmap, and then I can just draw some colors here, and it will read this terrain and convert it into a hex map to have these different terrain tiles. And then the other question is, we don't want to have them on uniform height all the time, so we need to generate some kind of height map. So what I do is when the game starts up, it will assign different noise functions to all the different terrain types. And then you can see, for example, that the mountains here are quite high. This one is completely flat. This one has like some wobbly noise function to it. So I can control that. And how this is rendered is that if you think about these individual hex tiles, the geometry on them is everywhere the same. You just have some triangles that are next to each other, like in here. So what we can do to render this entire terrain is we can use instanced rendering to render the entire terrain, what you see here, in a single draw call. And how we do that is we just create different instances for each of these hexagons, and then each instance just knows what terrain type am I, and also what position am I on. And then depending on the position I am on, I can just go into some height map texture and look up for all of my vertices at what height they should be. So the rendering is quite efficient. The frame rate is not so great when I do the demo here because I demoed on my laptop. It doesn't even have a dedicated graphics card. It just has some integrated graphics, so it's not so great. But for me, it's important to develop on a machine which represents like the lower end of the user spectrum. Yeah, so that's just a little bit about the technical stuff, and I'm open for questions if there are any. Thank you.
Yeah, super cool. So I saw the post on Reddit, and it was super cool to kind of, I just see like the one picture of what you're going for here. And I mean, you said, oh, it doesn't look very nice, but I'm looking at this, I'm like, oh my gosh, like I can see so many like cool games being implemented in here. And so just out of curiosity, with like the development sort of process that you're doing, I assume it's like a side project type of thing, but is there anything that you're doing to kind of like keep up with like a certain pace, or something that you have milestones you want to be hitting in the next few months?
Yeah, so basically every weekend when I have a little bit more time to work on that, I set some milestone. For example, right now, my next milestone is to rewrite the UI system, which I'll also use for all the card layout, because I really need to have some nice drop shadows there. For example, also drop shadows for text. And I want to use a signed distance field font rendering, because that's really important if you have cards that are like in 3D and you don't know at what distance the player will actually see the text. So it needs to be crisp, even if you're super close to it. And actually, I have a full-time job where I also write Rust, but I quit that job, and I'm focusing full-time now on the game. Yeah.
Nice. Okay, super cool. And so I like that. We saw a project a few months ago, Tanet, that was going for like a Steam release full project, and they were using Bevy, and so they had like a little bit of an engine to work with. But for yourself, do you find that there's any restrictions? So if I'm not mistaken, you're just using WGPU and then your own framework, right?
Yes.
Mm-hmm. So do you find that there's any restrictions in the game design when you have to build all these systems yourself, or do you feel that it gives you much more freedom that you need?
I think it just gives me much more freedom, because if I have a very precise idea of what the game is supposed to be, I need to know all the details anyway. And Bevy doesn't help me by abstracting away certain things or hiding things behind this ECS structure. And first I started to use Bevy because it's very big and popular, and it works really well in the beginning. But if you then try to dig into how the rendering works, there's like no clear code path that you can just follow to understand it or to implement some extensions on yourself, because the ECS structure makes it that everything is super distributed. Something happens here, then something takes some resource and happens here. And it was just really hard for me to reason about my code in that way. So I thought it's easier to just write everything by myself.
Yeah. All right. Well, yeah, super cool seeing sort of the behind the scenes on this. I'd love to see more Reddit posts. And of course, I'd love to have you on in a future month to give us an update on the progress. I think it's super cool kind of seeing, okay, we got the foundation, the fundamentals here, but also you have some design ideas that you're following. And so hopefully in future months, we can catch up with you and see how stuff's coming along.
Yeah, cool. Thank you.
Perfect. Thank you very much, Tadeo. And we'll be back in just a minute with Jan, who'll be showing us Yarn Spinner. Okay, perfect. And I'll just get you to share your screen as well. I don't think I see it up here just yet.
Yeah, just a second. Perfect. There we go.
All right. Good stuff. All right. Jan, I'll let you take it away. Tell us about Yarn Spinner.
Cool. Hi, everyone. I'm Jan Hohenheim, and I'm presenting a little thing called Yarn Spinner for Rust. And some of you might already know Yarn Spinner. It's quite a popular tool for writing game dialogues easily in Unity. Night in the Woods uses it, A Short Hike, Dredge, cool games. So now there is a Rust board. Yay! And if you want to try it out for yourself, like some eye candy first. Forrest, I send you a link to distribute to people. It's this quick little itch.io demo that I've set up here. I don't know if this comes across in the stream, but it runs really fluently, which I'm super proud of. And you can see how, well, there's interactive little dialogue happening here. And second here, blah, 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 blah. There you go. You can see that the camera moves according to events in a dialogue. Cool stuff like that. So what I want to show you is a bit how Yarn works, and we're going to do a little live demo. So this is the documentation of Yarn Spinner. You can see here on the left that this is the general introduction, because all of this is shared across Unity and Rust. And you can see all of the different ways that you can write. We're going to do that live later. And down here, we can see the Rust-specific parts. And you'll see that I mentioned a bevy here. That's because the binding to Rust, it's generic in theory, but I only have examples using bevy so far because I love bevy. But if you're interested in integrating this in your own engine or using it without an engine, on the GitHub repo, there are these language tests here that I took straight from the C# code, so it's testing the same data. And there you can see how you can easily see easily use the underlying structs and stuff. Cool. So let's look at how this works. So I'm using the official Visual Studio Code editor plugin that allows me to see these kinds of nodes. And the code powering this in Rust, first and foremost, is super simple. It's got a bunch of comments here, like for beginners. So we're going to be focusing on this yarn file here. You can see the running game on the right. And it works by creating these little nodes here. So nodes that have titles. This position is just for the editor here. And they have some kind of content. So you can write stuff like so I wrote something, and you can see that because of hot reloading, we are seeing our dialogue, including a little detector here for finding out the name of who just said something. And we write some more lines. We can advance the dialogue here. And let's show off some more features. We can have dialogue selection, like for example, what is your favorite animal? And now we can use these little arrows to indicate options. Here we go. And you can see these are our options. Now, nothing will happen when I click on these because we are not handling the part of the code that responds to this. So let's write something there. You can see that I can use some white space to denote the branching here. And when I click on something, you now see that we entered this little branch over here. Now, other cool stuff that we can do, we can set variables. We're going to declare $animal as nothing. And if we select dog, we're going to set animal to dog. Let's have GitHub Copilot auto-complete this. Perfect. And if we have a variable, we can interpolate it. interpolate it like this. And I did some kind of issue there. Oh, yeah, don't mind me. As you can see, we interpolated that, and we can do some simple control structures. In fact, you can see the GitHub Copilot is smart enough to help me out here. As you can see, we can do some ifs and else ifs and whatnot.
One thing I was just mentioning, could we just zoom in a little bit on the editor there?
On the code?
Yeah, or yeah, just on the full VS Code screen. Yeah.
Sure. Is this
Awesome.
better? Can people see that?
Maybe one more.
One more.
I think seeing
okay,
the,
I'm very sorry.
No, it's all good. It's all good.
I have horrible eyesight as well. I should have known.
No worries.
So let's remove these ifs again, and make this a little bit smaller. Yeah, just for the people who didn't see it before, you can see that this is a line in Yarn with a speaker and some text that is being spoken. Here we got a question, and these little arrows here denote branches in the dialogue. And here we have a variable. Now, these branches can also be bigger, of course, and they can have more branches and whatnot. And if you want to organize this a little bit, you can have multiple nodes. So let me just quickly write something up. There we go. And let's remove all of this complexity. We can jump to other nodes. And because we are using, oh, I'm using the wrong symbols here. There we go. Because we're using this cool little plugin, we can see how these nodes are connected, which is cool. And as I said, everything is live recompiled over here. So if you want to hear more about this, there are some cool GDC talks by the original creators of Yarn Spinner. The idea here is that this should empower your writers a bit. So if you're comfortable with like maybe some other dialogue creation tools, you know that they do not allow you some variable declaration or stuff like that. And this here does, so you have a bit more control there. Other things you can do is you can call functions that you define in Rust. I've got another example over here. Let's remove this tab. Yeah. Here you can see that I am adding a function, which from the Yarn side will be called pow, so power off. And this is my Rust function. And you can see that it has 2 parameters. And if I go into the Yarn code that calls it, you can see that I can do interpolation here by just calling this function natively, which I think is super, super cool. And one thing that was especially a joy working on this with Rust is that in the Unity version, this whole function adding works over runtime reflection, which means that you're going to get a crash if you did something wrong there. But because this is Rust, and Rust is cool, everything here is statically typed and works at compile time, which means that I in fact can only add functions here that work. So that's cool.
One thing I'm curious about here that you just showed off is if you can do POW to do some type, like you can write some operation in Rust and then expose it as a function to Yarn. I'm kind of curious, could you make some functions that allow you to change the design of the game or like make this design decisions? And so as you're writing Yarn, you can actually change how the game works?
Yes, that's a very good question.
Gosh.
You
That's
remember
so cool.
the demo I showed before? Let's open it real quick. Because this uses 3D models in the browser, it takes a little while to load, so give it a bit of time.
That's fair.
But you can see how the head is bopping of Ferris and how it's changing its its sprite and how the camera changes as well. I want to show this real quick, but oh no, it's not loading. Well, my computer is a little bit overworked now, but I can show the code for this. It's super cool. So there are these things called commands.
Oh.
You can see them here.
Okay.
Commands are like functions, but they change something about the world. And you can see fade in, show, bang, which is like this little, oh yeah, here. So this function here, fade in 1.7, is remove this black screen that I'm showing on top of everything over 1.7 seconds. And this little bang that you saw on top of there was this show bang on top of Ferris for this amount of time. Wait here, waits like before advancing the dialogue. Change sprite is this thing that you saw here. And on the Rust side, I have configured what exactly that means. So change sprite then, plays this whole animation and stuff. And you can do this like if you're coming from Bevy, these commands are just regular Bevy systems. So you can mutate the world however you want through a command. And in fact, you can return a task-like object to tell Yarn whether or not you're done with it. So one nice example I have with this is sometimes we don't want to advance the dialogue instantly. And let me just click through this real quick. Feel free to read all of the text I wrote for this on your own. And you can see now that the camera pans towards Clippy, and only then the dialogue advances. This is because I'm handing back a task that takes a little while to complete. And the Yarn side just deals with that automatically. I don't have to do anything special there. One other thing that I didn't mention yet is these are auto-generated. And this is here for localization purposes. So
oh my gosh,
let's see if
cool.
I can.
Oh, that's so helpful. Yeah, so you just like automatically gets added.
Oh, I'm super.
There you go.
Yeah, I'm super proud of this. So what you automatically generate. So okay, let's start like this. When you add the plugin here, I just created it with like this with new, but instead of just saying new, I can say generated with localizations for this and that language, and then Yarn Spinner will auto-generate for you this little CSV. Do I have a CSV viewer plugin right now? I do not. Yeah, so just imagine this was a cool table. And you can see that this is where I can put in my translations for anything. You see this this line here. This is this auto-generated ID that I mentioned before. And everything of this is pre-filled, and you can just simply change this text over here. And then, yeah, it uses whatever you have in your strings file with a fallback to just go back to whatever is written in the Yarn. Together with the localization feature, you can also deliver custom assets. So you see for the line 8, I might want to play a sound file. So I have this 8.ogg file over here that can play there as a voiceover, for example. And as you can see from my file system here, I have different assets for different languages that are being set. And yeah, if you like all of these features, they're all in the official Yarn Spinner documentation. Just scroll down for the Rust part, or read this part here that doesn't say Unity. You can find it if you just Google Yarn Spinner doc, so it will come up. And I think that's all I wanted to show for now.
Awesome. Yeah, super cool seeing the sort of like the process behind this, because I mean, as someone who focuses a lot on systems and not as much on story, like I very much get to the point where I'm like, oh yeah, okay, if I'm writing story for a game, it's going to be in an array and it's going to step through each one of them, and that's the best it can do because I'm not writing a better system. And so yeah, it's kind of cool to see behind the scenes on what like if you actually focus a lot on a narrative game, here's a good way to go about designing the
yeah, right. And I
process to be
especially
story.
like how simple this format is. Like, if you look at this is just a screenplay, right? This is just a script. Everyone can write this, and this is what I
Yeah.
really like about it. It's so intuitive.
Yeah, super cool. Well, Jan, thank you very much for showing off Yarn Spinner's Rust side of things. Yeah, it'd be cool. So I think it's really nice to see Bevy here. I'm super excited to see kind of where it can grow into, and like if you can either make it easy to support other things or for people to build it into their engines themselves. But yeah, this is definitely something I'm going to try to play with myself.
Happy to hear.
Perfect. Well, thank you very much, Jan. And we'll be back in just a minute with Graphite. All right, so we are back with Kevin, who's going to give us this month's update on Graphite. I'll hand it over to you, Kevin. Oh, I think you're muted right here as well. On StreamYard's. Wait, I can't unmute. Oh no, sorry, it's StreamYard's side of things muted.
Okay, there you go.
Perfect. All right, you're good to go, Kevin.
All right, hello everybody. I'm back with January's update on, or January and a little bit of February's update on Graphite. Jumping straight in so we can get rolling. First, I want to show off some new demo artwork that I've worked on over the past month. And this is on the Graphite website, on the homepage now. And here you go. You can see this is a hopefully nicely looking professional piece of artwork that now tops the homepage. And then, of course, you can always drag to the side and view the other artwork as well. So I'm going to open that one up now. We can just go to the Open Demo Artwork button and click on Red Dress. And it will open here. And what's really cool about this is that it's heavily utilizing the procedural capabilities of Graphite's vector editor. So all these points, all these circles that you're viewing, there's hundreds of circles, both those that are drawn along these paths, as well as those that are drawn within these regions here. So at the moment, we actually have caching disabled, so we have to re-render the entire graph, which means we have to recalculate the positions of all these points, which is why it's very slow, unfortunately, at this moment. It's like 1 frame per second. But once we have caching re-enabled, then it will be very fast again. But basically, I can drag these points around, these regions around, and it will now use the new node that exists called Poisson disk sampling. And what that does is it places circles all around within this area. So I could basically just drag and update the shapes, and it will continue placing these points. And then it will also allow me to randomly choose the distribution of sizes of these points as well. So in this properties panel here for copy to points, you can see I have any points scaled between 0.5 and 30, and there is a size bias towards it. So this allows me to say, okay, if it's a bias of 0, then there's an equal proportion of likelihood of any of these point sizes. I'm just going to maybe drop this down to like somewhere between 0.5 and 5 so you can see it better. So now every point here is equally likely to be of anything between 0.5 and 5. But now when you actually bias it more, it'll basically say, okay, it's more likely to have small points, but then occasionally you'll have some big points. Or you can say the other direction, it's more likely to have big points, but occasionally you'll have small points. As we can see here. So this copy to points node basically allows us to instance things, and the Poisson disk node here is what allows us to set a separation distance. So right now there's a distance of 5, but we could say we want them to be more sparse by saying now a distance of 10. But basically it means it randomly places the points, but it also requires that the points not be located within 10 of each other, 10 pixels of each other. And then, of course, you can change this around as you need. You know, you can go with something really dense by saying every point only needs to be 1 apart. And maybe decrease, of course, the size of the shapes themselves and bias it towards being mostly small. And as we can see here now, we have a very, very dense set of points that we can just barely see as like a little bit of a frosting of some dust here that almost looks like, you know, some red dust, essentially. There you go. And this, of course, would take hours to place by hand. And I'm not aware of any other tools that, any other full-on vector editing tools that specifically have this kind of capability of placing all these points at randomly sized, randomly distributed and randomly sized. So this basically allows you to make some really, really faster and more creative artwork, because it allows you to essentially sort of distribute points, and it doesn't have to be just circles, by the way. It can be any kind of shape. And on the previous meetup, if you were here, we also had the, oops, not this one. We had the procedural string lights. And of course, this allows you to place not just circles, but, you know, entire Christmas lights. And now that I move on to another feature, I would like to show we have this ability now to place, to insert a point at any point along. So we can basically click once, slide it around, and then click a second time, and that's where it ends up inserting a point. And then another new feature is that you can delete points now. And basically, when you delete them, it will actually just delete the points, the edges on both sides. So now they are completely 2 separate subpaths that are part of this one layer. So I can have entirely separate Christmas tree lights, for example. And, you know, let's say I want a third one, so I'll just split it again twice, delete that one. But if I hold down Control, that's when it actually deletes the segment. And now I have, you know, a third wire here. And then finally, we can also delete and turn what was a closed path. Previously, there was no way to turn a closed path back into an open path. So now you can delete it, and you have an open path again. Now you can do whatever you want with the open path. Yeah, so those are a few features that we completed this month. I'll close that and go back to this artwork. And okay, so that covers this one, as well as the Poisson disk node. Actually, I could just work on just a new shape so it's more responsive, and I could show what that looks like more now. So all I got to do is do you know, make a shape, and then I'm not even using the stroke color, so I'll just delete that. I'm not even using the transform either, but I can now just do Poisson, and that is the mathematical name for what it means to distribute points where there is no point closer than another point to one another. And right now, it's visualizing all these points as a polyline. So you're basically seeing each of these points of the polyline show up as one of the points, but now we can do instance the points, or copy to points. Put that here. And at the moment, we have this also, I think it's a new feature as well for this month. Anytime there's a failure in the graph, because the graph is missing information it needs to compile, it will display an error and actually point out precisely which node is giving that error. So it makes it really easy now to track down why the graph isn't rendering. But now you can do something like star, actually, instead of circle. So we have a star generator. Wire that up. And now, of course, the star has no color to it because we're giving the color here, but then it's becoming the points, but the color itself is not being used. So I'll just move that upstream here instead. So now we actually have our color. And of course, it's too big. So let's actually just turn the distribution down to being a little bit less dense, maybe 50 instead of 10. And of course, we'll also shrink the size of the star itself, maybe to like, let's say divided by 10 and divided by 10. We can now bring the distribution up a little bit. So now we can see it's pretty nice to interactively, just you click on one of them, use the path tool to move around the path, and simply update it like this. And then, of course, you can also change the size distribution as well. Yeah. So hopefully that is a very useful tool. And then, of course, we have another new feature, SVG import. So this allows me now, I'm just going to create a new document. this allows me now to import SVG images. We haven't had this feature this whole time, but now this allows me to rescue one of the pieces of artwork that we first made in Graphite about 2 years ago. This was a really old version of Graphite, and the file format has changed enough that it's definitely impossible to open this. But at the time, we were able to export it to SVG, and now we're able to import that SVG and basically rescue this file format, or this piece of artwork that was created a long time ago using a very outdated version. And of course, you can go and edit things. But yeah, so that's another really helpful feature. And we now also have the morph node. So this one's really cool. I'm going to go back to this, for example, and actually, yeah, I think I'll try and keep the nodes themselves. But right now we have this shape, and I'm going to now make another shape. Okay, so kind of a weird shape here, but what I'm going to now do is I'm going to say morph, create a new morph node here, and I'm going to morph from one shape to the other shape. Now reconnect that to here, and then I can actually delete the entire layer that this one was a part of. So now I'm morphing between the two shapes that I drew, and now we have stars placed in between. So I will now move the morph parameter, and as you can see, we are morphing from one shape to the next shape. And if we had an equivalent number of vertices between the two shapes, because one of the shapes is, as we can see, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think, vertices. The other one had fewer, so it's going to look a little bit not one-to-one. But instead, I can go from, for example, an ellipse to a rectangle, and these both have 4 vertices in each case. So now if I move them, or if I copy over the morph node to this, now we can see as we morph the parameter between 0 and 1, now it turns itself into an ellipse. And of course, now we could also we could move that over to being the parameter that drives the on disk sampling here. And, oops, that's rotation. And let's see. We are now driving the boson disk sampling. I think we just have the points being too dense and these shapes are too small. So let's go with some live debugging here.
Yeah, I was gonna say, like, as you're debugging this, I'll just talk a little bit. But I love that it's like, okay, it's not code exactly, but we still have to like think our way through the graph here. But this is super cool to kind of see the process of what it takes to go through. I find that like for myself, whenever I'm using like either like a graph editor or something where there's like a lot of things to tweak, it's like hard to know exactly where stuff is happening at each step here.
Yeah, exactly.
And also, okay, the debugging on top of the nodes, like when you have something, it's like, okay, this input is not compatible with this output. I love that so much, and it is so reminiscent to me of like the Rust compiler telling you that like you've made a mistake and here's exactly what you can do to fix it. So
yeah, and of course we want to make that just the beginning. We want to make it much more usable in the future by, for example, one of the changes we want to make is making it so if there's an error in one branch of the graph, we don't stop rendering the entire graph. We just display the error, but continue to render all the other branches of the graph.
That's so cool.
Okay, so here is another example we have here. So we can basically just morph, and it also morphs the gradient, as you can see here, as well as the thickness of the line, and basically any other render parameters that exist. It morphs those. And pretty soon we're also going to have a little bit of animation capabilities. So we'll have a timeline and have some a curve editor for your parameters, your animation parameters or channels. And then you can basically hook that up to the time here and animate any of your things going back and forth, or basically doing a morph from one shape into another shape, or one facial expression into another facial expression, or anything like that. And then of course it's always still procedural, so we can still do, I think, copy to points, unless this was somehow a bug from last time, we'll see. Circle, feed that in. We do need to give it color now because the color of the circle is now being what's used. So I'm actually just going to copy over maybe this gradient. And here we are. Now if I change the copy to points to be, or if I change, oh right, yes, if I add Poisson. Here we go. Okay, that's looking kind of cool. Now maybe change the size of the circle down to like 5. And yeah, okay, so now we have some interestingly distributed points, like so. And we can do some cool gradient things. And of course, if the gradient is downstream of the circle, it seems to use the actually, I guess that's the case either way. So it's copying the gradient over after the fact. I think we probably want to have it in the future so it copies the gradient over on a per instance basis if the gradient is displayed before the instance. And then if we give the gradient after the fact, then it would do it across the entire area. But yeah. Okay, so that is one other feature. Next one to show off is the grid system. So we have both a normal horizontal grid as well as an isometric grid. So you can basically specify, okay, I want this angle to be this amount. So let's say I wanted like a 10 degree and 10 degree angle. And now we have a 10 degree by 10 degree. Or we can say, and then we can change the Y spacing to basically increase or decrease the scale. But basically, let's go back to the regular 30-30 isometric. And now this basically allows me to very easily make shapes like this or any kind of like Escherian interesting artwork. So you click, you click, you click, you click, and then you can drag them around with a path tool and very easily make these kind of, you know, I can, for example, make a quick cube here just to show off live how this works. And then at any point, if you want to just turn off snapping, grid snapping, you just turn off the grid there. And now anything that you're drawing with the pen tool is going to be freeform. So very easy to turn it on and off like that. I'll just finish up the last one. Actually, I can probably duplicate this one. Use our flip tool and then put that into place. And then change its color. All right. So yeah, very easy to make these modifications with the new snapping tools. Oops, I double clicked, which converts. Oh, actually, maybe it automatically thinks I double clicked when I didn't. Okay. Yeah, that is that feature. And then, of course, we also have horizontal grids as well. So you can switch over to this and then, you know, create like a very nice grid-aligned shape here. And of course, as you zoom in more, this will be by default a 1 pixel by 1 pixel grid. But when you zoom out, then it gets down to like a 2 pixel and a 4 pixel and 8 pixel and so on as you continue to zoom out. Okay, yeah, and then we have the freehand tool append node. So if I go back to that Christmas tree demo, this allows me now to use the freehand tool. Oops, that's not the Christmas tree demo. This allows me now to use the freehand tool, which is this one, and I can now simply click and drag and extend an existing line. So if I maybe split this one up, for example, again, so delete that point, and now I go to, oops, here, I can now continue to, whoa, I think I just froze something. Possibly crashed it. I'll have to look into that later. What else would we have? Actually, that's everything. Good time to crash it. All right, on to questions.
Nice, super cool. I feel like I had some questions, but I was like, just like loving watching everything that's coming along here. Oh, actually, one thing I was kind of thinking about. So, at first we showed like the Poisson distribution within an area. And so I very much look at a lot of things that Graphite does as very dynamic things, or maybe like emergent behavior when you put stuff together. And this is stuff that I feel like I haven't seen as much in Photoshop or as much in Illustrator when I've used it. And so is this something, or like, maybe like how do you think about these types of features that you add? Like, is everything sort of just like that some other piece of software has done it and we want to as well, or how much of it is like it would be really cool if we had this thing and just let's build the systems around it that lets these like really interesting interactions happen?
I'd say it's kind of a mix of both. Partially, it's motivated by having a piece of artwork that I want to be able to make. So in this case, the red dress example was the motivation behind both the copy to points scaling system, as well as, of course, the Poisson distribution themselves. And then we already had the sample across points, which basically allowed us to convert from if I can very slowly select it. Give me a second. So, for example, these here are also generating a very dense polyline, placing these points evenly across the surface. This is basically the same as how we did the Christmas tree lights. Oh, but I have... It doesn't seem to be selected. Oh, there we go. Okay, so as we see, we have a pretty normal curve here, which only has an anchor point here, an anchor point here, an anchor point here, an anchor point here, here, and here. But then we have the other node that will distribute points evenly around or along the curve here, and that allows me to do the same distribution of circles with that copy to points node, allowing me to use that resizing functionality that we use also, especially for this kind of shape, using the Poisson distribution. We also use that same shape to give us a little bit of like a size wobble between. So for example, in this one, especially in this one, you can pretty easily see that we have some big ones and some small ones based upon the same size distribution here. So essentially it's like these building blocks. The nodes provide capabilities where it might be useful to have, you know, the change in size for this kind of use case, but then you bring it over to this kind of use case, filling the interior, and you're basically able to reuse those building blocks across both use cases. And the potential and the capabilities, the features you can actually use with your own creativity will grow exponentially as we add more nodes, and as we also, of course, add more tooling around those nodes, so it makes it easier to modify. You know, modify the shapes, modify the graph itself. Any kind of tooling or changing that you're making should all be able to be hopefully pretty seamless and easy for the user to modify.
Awesome. And then one other thing I'm curious about. So seeing a lot of these systems that are put together in complex ways that I might not creatively think about in the first place, what does the tutorial system for Graphite look like right now? Like, if is it possible for me to follow along on some of these demos or like these example projects and follow along to make something like it myself?
Yeah, so last month, we did talk about how we have a new learn section here, which has our first tutorial. I'm hoping pretty soon I'll be able to record the next tutorial, but it was pretty clear what I wanted to do for the first one, and I'll have to figure out precisely what the topic should be for the second one, because it should be a little bit more advanced, but still a gentle introduction to the overall systems. I think a pretty obvious one will be making sure that we talk about the node system, which we briefly cover in this first one. We go over how to create this happy sun, which involves a circular repeat of the rays around the outside, and that kind of finishes off that tutorial here. With how to use the node system a little bit to make those circular rays. But getting a little bit more advanced, maybe with the Poisson distribution sampling or copy to points, that might be a good way of kind of introducing these systems a little bit more concisely, but also with a little bit more capability to it as well.
Okay, nice. Yeah, well, it's super cool seeing where Graphite has made some changes for this month. So, Kevin, thank you very much for showing stuff off, and I hope to catch you next month.
And as always, we'd love people to get involved. If they're interested in any graphics programming, it's very easy to get involved by just making a new node. So please, by all means, stop by our Discord and let us know that you're interested.
Perfect. All right. So I'm going to take us over to here. So for the last presentation of today, we're going to be hearing about RPGFX. Now, I have a video that I'll be playing. I'm going to give a little bit of context to the project ahead of time. And so we have this project, RPGFX. It's built in Rust. It's in the browser, and so it's using WebSys, Serde, and Rye. we'll kind of see how it's going along, and at the end we can go through some questions with Ryan. But it was just pre-recorded because Ryan's a little bit under the weather, and so just making it a little bit easier there. So without further ado, I'm going to open up the video. Now, just for my first time trying it with this way on StreamYard, so there might be technical difficulties, but we'll see how it goes.
RPG Studio is a browser-based game-making engine. It's written in Rust and WebAssembly. There's very few additional crates, no outside UI or graphics libraries or other dependencies. The only non-core dependency right now is RiScript for scripting. This is RPG Studio FX, and it can be run in the browser. There's nothing fancy you have to download. You simply go to the page, and after it loads, it opens. If you have slow internet, it might take a few seconds to download files. The WASM package is over a megabyte now, but you can start making video games right in your browser using RPG Studio, which I wrote in Rust. This is like a pre-alpha sort of release because there's a lot of things that still need to be worked on. And little tiny bugs here and there. I've been focusing on the core functionality. So we can click play game or play now to start playing kind of this default game world that I've been building as a demonstration, or we can start by making our own game. To kind of see what's available to us, we'll click play now and see kind of this, role-playing game world. I'm controlling the character with WASD keys, left, right, up, down, etc. I can walk and pick up items, so I just picked up that sword. It changed the tool that I have here, and of course the user interface and things like that are, these are all first drafts and probably nowhere near what the final product will look like. Combat exists. This spider just attacked me, and I can dodge it if I'm really good, and holding the space bar activates whatever tool is in my toolbar, so I can slash and attack spiders. I don't like this animation very much, so that's going to change in the future, but that's one of the mechanics. You can fight things. The creatures you kill drop things, and you can pick those up. Inventory, all those things you need in the game are just being added now. There's monsters that can shoot at you, and they can hit you. If we let those two shoot you, you die. Currently, in this game, you just respawn back to where you start. The idea being you can create almost any kind of game imaginable in this engine. It's not just for role-playing games, but I'm building it with the idea in mind that role-playing games are easier to make, and that's what I want to target first. Eventually, any kind of game will be makeable here. What I most recently added is scripting. So when you say collide with an entity, it's actually executing scripts. Here is the editor, and I'll show you those scripts in a moment. But if we refresh, we can just go back to get rid of all that from the default game and click make a game. And so this is kind of a generic blank starter that you can then make your own game out of. When you select a game chip, it becomes a tool down in your toolbar, which also means that there are some interesting ways that game developers could make editing the game part of their game, if that's something that a mechanic that might work with your game. So you can take tiles and simply draw on the world. Some basic auto tiling stuff going on here. We've got all kinds of tiles. Some of these I still need to replace with different assets, but like walls and rooftops and things like that all tile correctly. Pressing X can hide the editor so you can see kind of the world as it exists. It's silly to edit while the game is running, because now these slimes are attacking me and killed me, and so that's inconvenient. So you can just pause the game and then edit the world around you. So there are infinite layers as well. So we could create a new layer, click that layer, increase its Z position, and then we can draw things on that new layer. And whichever layer you have selected is what's highlighted, or you could select none. But that allows you, there's an infinite number of layers you can add to your game. If a layer is above the player, it becomes invisible when you walk under it. So this layer is layer 3. The player is on layer 2. There's a little P icon for where the player's at. And you can actually change most of those details, but you'll see that part of the roof gets hidden because we walk behind it, so you can kind of walk behind the house and things like that. Getting the drawing right takes a little practice. If you're familiar with other tile-based editing systems, you might understand how to draw those tiles perfectly. Our chip list lets us draw any chip here too. That may be a little silly and need updating in the future. For example, I can draw a dog, but it's just a dog icon, and technically I'm under that icon rather than actually being a dog. See, if I click play, nothing happens because I simply painted the chip rather than actually creating a dog entity. So for entities and objects, we have the ability to grab entities, move them around, edit them as necessary. Currently, entities have interactions and behaviors. These behaviors, the idea is to give some basic functionality. I want game design to be a little less like Unity and a little more like Photoshop, where you can just apply really common things. Like a common attack is hop at player, and that means, you know, the slime's going to try to hop at me if it gets close enough within this distance, fleeing if it gets attacked, dropping items, etc. One of the key things that I've been working on and still needing to refine is these panels. You can drag your panels anywhere for whatever object you're editing, change their size, etc. But you can see there's still some glitches and bugs to be worked out with the whole UI system, but it's designed to be as flexible as possible so that you could, say, edit an entity, edit it, the way it interacts with the world, etc. Drawing the map here, you can draw as big of a map and world as you want.
No. Oops. Okay, 1 second. Oh, geez. I was doing stuff on the computer that was sending the video. I wasn't even thinking about that. Oh my goodness. 1 second. Let me see here. We love technical difficulties. Okay, I'm going to take a quick look and see if it lets me easily.
RPG
Oh my gosh, okay, thank
Studio
goodness I can
is
scrub
a
through.
browser-based, where it says load game. The idea here is that anyone can make an entire role-playing game world that they want to really easily. And for other types of games, there's scripting. None of these creatures have scripts except this goat here. So we can click the goat and we'll see it's got an interaction defined. And as you can see, my interface still needs work here. But this interaction has a script which is written in RiScript, and I'm currently working on exposing more functions to the scripts so that you can, you talk to the goat, maybe the goat runs away, etc. Currently, speak actee would be the entity that collided with the goat, and actor would be the goat itself. Or actor would be the person that collided with the goat, and actee would be the goat itself. And so the goat then says ba when you touch it. You can change the different sources for interactions as well. So that means you could have creatures that interact with each other. Maybe if the dog gets too close to the cat runs away. You can do all kinds of things like that. You can change the type of collision to on collision, start collision, end collision, etc. Making it so that you can create, say you stand in front of a door, the door opens for you, and then you're no longer in front of the door can close behind you. Stuff like that is really easy to do in the engine, or the plan is for it to be really easy to do in the engine. Those functions aren't quite exposed to the scripting language yet, as I have to expose things one at a time because the scripting language is not Rust itself, and anyone can make their own game and scripts, and we want those to be safe for the end users. If we refresh and go to this default game, we can see more creatures, more things. We'll go down to, say, this cat and see that it's got its interaction is much bigger. The script is this is a different function, speak any, randomly chooses one of the strings here to say. You can close panels anytime, there's no problem there. And then the cat, says a random thing as you walk past the cat. The idea being you can create items, you can create entities, drag them out into the world. Currently in this kind of pre-alpha version, we can take an existing entity like the cat, we can duplicate it, and we can just duplicate it as many times as we want to, and then play, and then as soon as that cat gets to its next walking position, we'll see that we've created quite a few of them. Kind of, if I can separate them out here a little bit, they might decide to start doing different things. I think they're chasing me right now because they have this get attention behavior, and so they're kind of, if I kind of go far enough away from them, that might let them do their own things. You'll see some of them doing some weird things because I have not thoroughly tested all the behaviors. So if they're trying to walk in a certain direction and then they don't manage to reach that destination, the behavior isn't yet programmed to kind of be smart about those situations yet. But as you can see, millions of scripts are being activated as I walk through here. Well, not millions, but a ton of scripts are being run, and there's no noticeable lag. So the scripting language is relatively fast, which should be nice for a game that's mostly built on scripts. I can see someone building, say, a star shooter type of game where you have spaceships and things and objects to avoid, and all of that is doable inside the engine here. Currently, some stuff like the behaviors aren't yet editable. Those are the little details that I'm still working on. The idea is that eventually there will also be components too, but these interactions and behaviors are sort of a static type of component that we assume all entities have, because it makes rendering so much faster than trying to loop through dynamic types of behaviors. Your map's starting point here is a entity as well. You can change the type of entity too. This little invisible square, for example, is a spawner, and it's what spawns this slime. But say I wanted to make it, I'm gonna go get this sword here, kill that slime, and then kind of show you how the type of entity affects the interaction with the world. So if I fight this slime, another one came up. All right, well, let's just click the spawner. We'll change it to a creature instead of a spawner, and now it has its own health bar. So I actually just killed the spawner, and now it's gone forever. So I would have to create a new entity and modify it. Those projectiles, I wonder if I can click one fast enough. If I can get off the sword here. Those might be animations. Yep, I can't click those projectiles fast enough. But these entities, you can click any entity in the world. If we get the entity grabber tool, we see we've actually clicked the spawner underneath this little shooty guy. Here's the little shooty guy, and he can shoot, you can specify the milliseconds between shots, shot speed, distance, eventually specify which type of shot, animation, stuff like that. So you can make a bullet hell type of game. These carrot entities really have a spawner that then spawns another type of entity, which then spawns another type of entity. We'll do it real quick, and you see this carrot spawner is going to spawn a parent type of thing. Oh, actually, I dragged this one away. So this one is now spawning growing carrot plant, so you can make a farming simulator. This growing carrot plant here is just a sequence of spawning things that then unspawn themselves. So for example, if I take the entity and then I wait for this to spawn we can see that that's an entity that spawns the next stage. So plants have this kind of growing cycle. So there's elements for making a farm simulator game. There's elements for making an action role-playing game. The idea is to make an engine that is flexible enough that you can make any kind of game you want. There's background animations that can be made as part of the game's tiles. We'll see the water is here on this layer. Above it, you can see the kind of grass that defines the water margin. And on the layer, we can change the animation speed so that it moves faster. So say we have really turbulent water, we can just make that animated faster. And that's the milliseconds between each step, or the total milliseconds for the animation. A lot of entities can be created from spawners. The idea is we'll have a database of default kind of creatures and entities and objects to interact with and deal with in the future. You can create maps, so you don't have to have just one game map. So we can switch between our game maps anytime. So say this new map could be inside of a house. We'll find something that looks like kind of a house wall interior. Select the layer. Draw some walls. Pick something that looks like a floor or carpet. And you can see we're kind of inside this house now. Get a kind of top to go around the house. And you can create all kinds of different worlds and types of places once I finish the ability to modify your own chipsets and tiles and bring those into the game. Currently, that's a little buggy. We could draw like the front of the house here, so we know like, okay, we're inside the house now. And the idea is, say maybe this house is, we'll go to the map. Say maybe that house represents the house that's over here. We could create an entity here-ish that would then enter the house, or we could create a door entity that you interact with to enter the house, and that would have a script that has a teleport map action. The idea being that you shouldn't be limited by the engine. You should be able to do just about anything, make just about any kind of game you want in the engine. The game runs in the browser, the engine runs in the browser. It's all meant to be as accessible as possible to anyone who wants to make a game. So that's RPG Studio FX, and what I have so far. There's a giant list of things to finish and to polish, but it's possible to play around with it right now just on rpgfx.com.
All right. So Ryan, I brought you here on stream. I think I'm on mute. Okay, perfect. I was trying to share my screen, but it wasn't working. But yeah, this was super cool. Kind of hearing about the process behind RPGFX. And so one of the things I was kind of curious about, and I'm also like recollecting the stuff before I made the mistake of pausing the video, but so with this, the project isn't open source, but you're thinking of potentially making a commercial product. And so what might that look like down the line for someone to sort of be able to use? Like right now, it looks like you can make a bit of a game, but what are some of like the steps before release?
Yeah, well, I last night just finished the ability for people to upload their game to the server. The idea being that you can make a game, save it directly to the server, and then just send a link to people with your game so that they can just go to rpgfx.com/yourgame. The idea could be, you know, I'd be interested in this being open source if I could make a whole bunch of money maintaining it. But I think a commercial product where, you know, maybe I let people make mobile games and there's microtransactions or something, and we host the platform. Well, that would be quite a lucrative endeavor there. The idea being making the engine so feature rich that anything you could do in, say, Unity or another platform, if it's 2D, then we can do it. Maybe in 5 years adding 3D, or if I get like venture capital. But currently all the drawing is just in a HTML5 canvas 2D context, because I don't want to write shaders, and WGPU and all that is still too complicated. Maybe I'll pick someone's rendering engine from earlier and integrate that in the future.
Nice. And kind of like on this topic of building your own game, I don't know if I can easily switch to different screens here. I think I can. Okay, perfect. So I think one of the coolest things that, I mean, it just popped up. I'm like, that's such an interesting dynamic, is you're making a game and slimes attack you. I thought that was so funny.
When we were moving the carrots around, the spider just kept bothering me. I hate spiders in real life, so it feels very real to me.
Yeah, absolutely. And so when you're like putting this game together, like you're making a game, you're going through like the process. You described it as sort of making edits to this more like Photoshop than like a full game engine. But we still have quite a lot that we can control on sort of like each entity's scale and stuff like that. And so what I was kind of curious about is, have you gone through the process of kind of saying, okay, I'm going to try to jam out a game, I'm going to try to put something together. And do you find any interesting things that you did differently than other engines?
So I keep having ideas for games, or games that I really want to clone and put into the engine. But every time I do that, I come across, okay, well, first I need to implement this feature. And then I try to, you know, play with another project. And then, okay, well, now I need to implement this feature. So if I just keep doing that for about another month, I should be able to make anything.
Nice. And then I mean also with like these entity screens, and I don't know if I can easily like switch to another one. I don't remember where the cats were, but you said something. I forget the exact line that you said, but you pulled up a cat and you're like, maybe something like its interactions aren't that complex or something like that. But then it made me think right away to I don't know if you've heard the story about Dwarf Fortress and cats getting like some interaction allows them to get like alcohol in the fur, and then they start dying from alcohol poisoning and everything. Do you foresee that you could add some complex types of interactions between the entities so that you could have these emergent systems coming out?
Absolutely. That's kind of one of the first games I want to build once I have all the scripting available. An open source game I was working on in Bevy is called Colony, and you'd have little entity units, and they'd all have their own kind of AI and their own behaviors and things like that. The idea is I want to make a bunch of drop-in behaviors, and then you can script your own as well, but we could create characters that, you know, have thirst and hunger metrics and get things, and cats that dig holes in the yard, and then just kind of see how they interact, because all the collision detection is run on every entity, so you can make any entity interact with other entities, make the cat run away from the dog, make the, you know, goats eat grass, things like that. So the idea is you know, trying to make an engine so flexible that who knows what happens when you create enough entities with enough things going on in them.
Yeah, and I really like that idea of cat digging a hole and kind of just like the stuff that comes together. And then also, I mean, sort of trying to create a Dwarf Fortress cloner, like in something inspired to see how stuff interacts, or just take other ideas. I think that's a really great idea, because I think when I hear engine that can do anything, like I think a lot of engines can do anything, but it takes a lot of my own creativity to come up with the way to do anything. Whereas when you can just start, when your way to do anything is to just mess with how stuff works together, and then you build out from there, I think that's like a really cool way to approach it. And so and just out of curiosity, so you mentioned that this is like so WebSys doing everything on the canvas. And so for the code base, have you like what state is it at? Like, is this the first iteration that you're building, or have you like refactored a whole bunch of stuff? Do you want to tell us a little bit about that process?
Yeah, so I actually built this project, but in JavaScript, like 4 or 5 years ago. And I got about 3 to 4 steps before where I'm at now. This is way more advanced. When I came across the limitations of JavaScript and things were just too slow, and all my entities and the rendering, after you added like 30 things to the screen, it just got really laggy no matter what kind of device you were on. And I'm like, well, there's no point in continuing with this. Now I've got I kind of refactor as I go. There's been several times where I'll create something like these fields that allow you to edit entities in the world. First, I pass things to the field and pass things to the panel, and then I realized, well, with the mutability and borrow checking rules in Rust, I've been getting really good at realizing, okay, well, if I'm going to edit any other part of the game, I have to pass the entire game. I can't just pass something that the game owns, because then I've got 2 mutable references to the game. So constantly refactoring as I go is part of the process already. Whenever everything, I've got just a few tests, but when everything passes CI/CD from GitHub Actions, uploads it directly to Website Raven, which is this Rust-based server that I built too, where people can build instant websites. It's buggy, not quite. I haven't spent as much time on that as this, but it just pushes the files right there. And so as I make updates, the rpgfx.com site is just live updated. So maybe in a week, I'll have 90% of these features done, or maybe in 3 months, who knows?
Awesome. Well, Ryan, thank you so much for showing this off. It's really cool, because like I think from the outside, like I see like sort of the view of, okay, it's like an RPG maker and stuff like that, but diving in, there's so much more to it. So I'm super excited to see how everything comes in the next few months, and hopefully we could have you back on at some point to hear about the updates.
Thank you very much.
Perfect. All right, so I'm just gonna put myself on screen. I tried to share my screen, and then more stuff like it looked like it was gonna crash, and so wait, I might be able to if I just go to Okay, I don't know if I've Chrome. Oh, there we go. Okay, so you can see it on this screen. Okay, so one thing I wanted to mention. Okay, you can see it on the screen. It's like 520p or whatever, but we're working on getting back up to speed on some of the content that goes on to the gamedev.rs site, and you can't see anything on here. It's purely white. But I've been talking with some people who want to help get the newsletter back running. It's been quite a few months since we've had a post on there, and there's like a lot that's like it was like in progress. We just need to push it a little bit. So I might try to put in some work to find some other volunteers that might be interested in helping out with editing the newsletter and getting just other content out on the Rust Gamedev website, just so we can keep seeing the awesome stuff that's happening in the community. I've heard from quite a few people that they've missed the newsletter and kind of seeing the heartbeat of what's happening, and so figuring out how to get back on top of that efficiently. And so if you're interested, feel free to reach out to me. You can just send me a message on Discord, or just ping me in the Rust Gamedev Discord server, and I can get you in on some of the details on how you might be able to help. So with that being said, that was a super awesome month. I think like this reminds me a lot of the first Rust Gamedev meetup we had, where we had I don't know how many presenters, but I feel like we went for like 2.5 hours or something. We were just like showing off so much cool stuff and just talking about it. And so it was a lot of fun to see everybody sort of like having projects to show off, and just like a lot of new stuff that's going on. And so I'm super appreciative of all of today's presenters. And as always, if you're free for a few minutes after this presentation here, or the meetup here, we hop over to the Discord server, and there's like the Hangouts channel there. So feel free to hop over and chat with some of the speakers if you like, or just talk about what you've been working on. But with that being said, thank you very much for coming out to the February Rust Gamedev meetup, and we'll see you next month.